Hello and welcome to the second video in our DSA problem solving skills. This video is about the topic strings. This question that we are going to discuss today, it's a very interesting question because the first time I tried this question, it was in the order of n square. And then when I solved some test cases, I realized that it was giving a runtime error. And then I went to the discussion section and someone else had put this amazing solution, which is very efficient. It is a little bit tricky to explain, so I hope I do a good job. Let's start. Okay, so let's get started. This is the question, longest substring without repeating characters. Let us give it a read. Given a string S, find the length of the longest substring without repeating characters. So let's say, for example, if our string is ABC, ABC, BB, the output is 3. Because that string could be anything, ABC, BCA, CAB, again ABC. So these are the substrings which have the length of 3, and then there are a lot of substrings which have the length of 2 as well, and then finally a substring which has a length of 1 as well. I think the question is very straightforward and shouldn't be that much of a big of a deal to understand the question. So let's just quickly hop over to our board to see. Okay, so this is the question. We have been given a string ABC, ABC, BB. And we need to find out the length of the longest substring in this. So obviously we can see from our observations is ABC has 3, BCA 3, CAB 3, again ABC 3, then BC only 2 because B is getting repeated, so only 2, CB again 2, and B is getting repeated after B, so the length of the string will be 1. So if you see here, the answer should be 3 because that's the maximum of all the integers. So let's see what we do. ABC, ABC. So the first thought which comes to the mind, which is the most natural approach for this, is what we discussed in our previous problem for arrays. So what we think is we can have two for loops. Let's say integer index equals 0, less than n, plus plus, and then we can have a temporary variable, say n, which could be equal to s of index. And then we can have another for loop inside this I equals 0, less than n minus, sorry, not 0, it will start from index plus 1. Index plus 1, less than n plus plus. And then obviously in this for loop we can see if s of I is equal s of index, we can go on about this by increasing count. We will define a variable count somewhere here, and then another variable will define mx, let's say, which will be an answer. We can name it anything, mx or answer. And then at the end of this for loop, we will do mx equals to max of mx or count, and then that would be our answer. The only problem is the time complexity of this problem is n squared. 2 for loops, n squared. Pretty straightforward. This is the approach which I tried initially, and it failed because it gives runtime error at some point in some of the test cases. So we need to come with a better solution. A solution which has time complexity less than n squared. And then this amazing approach, which I came across from the discussions tab of Leetcode. It is a bit tricky, but let's try thinking about it. So our index approach is not working, which means what we do in our index approach once again is we take an index, and for the rest of the length of this string, we see where A is getting included, and then we take the length to be this. And then again, we will take this B as index. And then for the rest of this array, we will see where B gets repeated. And then this will become a count. And then we get the maximum of those two counts, and then we see where the answer lies. But this approach is not working. So let's see if something else can work out there. Okay, so bear with me. It will be a bit tricky at first. Why not start a pointer? Start from -1. Let us start a pointer from -1, let's say. And then before that, one more important concept. As we know, we'll have to declare a vector int of size 256. Why 256? Because the extended ASCII has 256 characters. We know the ASCII, normal ASCII has 127 characters, but the extended ASCII has 256 characters. So we must take 256 to be on the safer side. If we read the question carefully in the constraint, it is clearly given that the characters of the string can be alphabets, numbers, or symbols. So we can take a vector of 256 places, which is the ASCII, extended ASCII. So we will initialize this vector. We will initialize this vector. And then we start one pointer, start from -1. So let's see what we are trying to do, what this approach is telling us to do. So what we should do is we should iterate through this string as usual. I equals 0, less than n, I equals plus. What we should do is we should see if we should have an if condition, and we should see if b of s of I is greater than start we should make start equals to b of s of I. Obviously, there's a code after this as well, but we really need to understand this first. It's very important. So what we are doing or trying to do in this approach is, sorry for that cut, my phone camera literally fell. Okay, so let's begin again. So we are starting a pointer start from here. So what we are trying to do in the code is, let's give index into string. So what we are trying to do is, as we iterate through this loop, what we want to do is this loop b of s of I to be the value of this index I. And why are we doing that? What we are doing is, as we know, v of a, it won't give an error because a is not an integer. Obviously, it will take the ASCII value of a. Hence, therefore, we took 256 characters in our vector. So what it will do is it will store the integer, the index of a, wherever a is coming. And then it will see in our code that whenever a is repeated again, let's say for 3, what we have to do is we have to subtract this 3 from this 0 so we can get the length of this substring. And then obviously we point our start to the place where this character was initially, because then we don't need to start from starting, let's say from here, we'll need to start from here. Let's see it one more time from in a clearer view. It is a bit tricky. Let us see this one more time. We are starting a pointer start at -1. So what are we trying to do there? We are trying to find the length of the substring on the right side of start till any of these characters is repeated. So what we do is, as we are going through this array, we will give the value of this, let's say v of a for our first iteration, and we will give it the value of its index 0. So in our second iteration, what will happen is v of b will get the value 1. In our third iteration, v of c will get the value of 2. Right? What happens then? Then again we come across v of a, and this time it is equal to 3. So we give it the value 3, but we change the star to the value where a was v of a previously was. The value of v of a before it became 3, before we change it to 3, it was 0. So we give the star the value of index 0. So now when we are seeing the length of the substring, as you will see in our code, we won't start from the right side of -1, that is 0. We'll start from the right side of 0, which is 1. So we won't get this length. We will get this length until, of course, b is repeated. So we are getting exactly what we would have gotten in the two for loops approach, where one was index, just in one for loop and n time complexity. So let us see this one more time before we jump to the code. As I said, we might be required to watch this video maybe more than once. Okay, so let's see it again. Let's get it. Let's iterate through a loop of the length of this string, and then we'll realize how this code really works. The coding part is easy, just the approach is a bit difficult. So when the value of I is 0, v of a becomes 0, and we move on. B 1, because that's the index of C 2, because that's the index of C. Now again, v of a, it should be equal to 3 now, because we are here. But before that, we'll trigger our if condition so that start gains one place. The start goes to the value where this character originally was. So now, what the start initially was -1, now it will become 0. And 3 minus the value of start now is 0, so it will become 3, and that will be our answer maximum for now. Then we iterate again. Now v of a is 3, now v of b. Now v of b should become 4, because that's the index of b. But did we have a value for v of b before? Yes, we had. What was it? 1. So start will become 1 now. This is where our pointer will point now. And the v of b will become 4. And then the answer will become v of b minus start. Right? Index the I minus start, which is 3. So what is this 3 saying? The initial 3 was saying the length of ABC is 3. This 3 is saying the length of BCA is 3. Why not 4? Why didn't it go ahead? Because B gets repeated again. So this string also has the value 3, so our answer doesn't change. Had we had something, a substring in this string, which had which went through 4 characters without repeating any character, we would see that the max function would take care of it. Now again, let's go through this again. So v of c, what is it? 5. But what was it before? It was 2. So it will again trigger our if condition. So now start will become 2. So now start is pointing here. And the next case is when we iterate to the next cases, it will be looking at this suburb, looking at where it goes. Right? And now the length of substring becomes 5 minus start, which is again 3. What does this tell us? The length of substring CAB is also 3. Let us go through our loop again. B of B, what is it? 6. But what was it before? 4. So now start will go to 4. And now the answer we are getting is 6 minus 4, 2. Will we consider this? No, because we have already had bigger numbers, so we won't consider it. But from the point of view of understanding, what does this 2 represent? It represents that where start was before, here C. I'm sorry. It represents that the length of this substring BC is 2. Why not 3? Why did it not go ahead? Well, because the character B gets repeated. And so on and so forth. I think this should be clear enough. So quickly have a more, and then we'll jump to RBS. One second. That's setup done. This should be a fine place. Okay, let's begin. So the name of the problem is the longest substring without repeating. That should be good now. This is the code snippet, and now let's just tidy it a little bit, and we'll copy the function from right here. Right. So this string is ABC, maybe. That's correct. Okay. So let's begin. So how many variables do we need? We need start pointer. So not a pointer per se, but you know what I'm saying. So it starts from -1, and then there's mx, which is our answer. We can say answer, so it doesn't matter. And then we have to declare a vector of integer type, and I'll declare a vector of 6. This way we don't have to sorry, we don't have to main set it. All the 256 indexes will be started with -1. Now let's begin with our for loop. 0 list plus. Okay, pretty basic stuff. So what is the condition which we want to trigger? We want to trigger. Before triggering it, let's see what we have to do in the iteration. So we have to make v of s of I equals to its index, right? And as we discussed, mx would be equal to the max of mx and I minus start. As we have seen, we can say I also, and we can say b of s of I equals also, because that's I only. So in the explanation, I explained it in the way of the index of character, which is I only. So I mean this, you can read about them. Now, what is this? What is the condition which we need to trigger? This is the condition before assigning the value, because remember, for start, we need to point to the index of the character where it initially was, not where the repeated character is. So we'll assign the value later, and then first we'll apply this condition. If v of s of I is greater than start will be equal to v s I. So we are equating it to v of s of I before we are assigning new value to v of s of I. Hope that's understandable. Return mx, and I'll see out this because it's an integer type. The function returns an integer type answer. So let's see if it's working. Okay, it is working. The answer is 3, which was the answer of our test case as well. So I'll just copy this part and go to our base Leetcode screen. And let us first run our code here just to be double sure about it. Okay, it's accepted. And let's submit it and see how our solution fares with other solutions of C++ language. As you can see, it is faster than almost 63% of other submissions, and takes less memory than almost 60% of the other C++ solutions. It has done pretty well. So that was my solution. Do let me know if you have any better solution or if you have some trouble understanding it. I would really suggest to see this 1 or 2 times or do this problem 1 or 2 times, because this approach will be really helpful. Thank you.